Hello all, I am Dr. D. Praseeda, working as Assistant Professor in the Department of Civil Engineering of VNR VJEC. Today I welcome you all to the lecture on the hydration of cement and the heat of hydration. So what is cement hydration? So hydration means a chemical reaction what actually do take place when water is being added to the cement. So what happens in here? When water is being added to the cement, the both compounds what are going to be present in the cement which are the C3S, C2S, C4AF and C3A, they do react with water individually and results in the formation of the hydration compounds. So this whole of the process which is going to get involved in when water is being added to the cement is known to be as the cement hydration. So we all know the cement hydration is of very complex in nature because we do see in many of the hydration compounds are going to get formed as a result of the chemical reaction what do take place between the cement and the water. So the main compounds what are going to be of more importance in nature in enhancing the strength are the CSH and the CH. And CSH we all know it is a compound which actually densifies whole of the matrix of the cement which enhances the strength as well the durability performance of the matrix. So this is whole of a mechanism what is going to get involved in. So figure 1 if you could able to see in the cement particles are being in a loose state. So when water is being added to it, there will be a dissolution of the cement particles that do happen in the water which results in the formation of these hydration compounds which are brown in color get precipitated on whole of the periphery of the cement particles. So with time there will be a densification of the matrix that do happen in as seen in figure 3 with leaving only small pores in the matrix. So this is how whole of the cement hydration do take place in and resulting in the formation of hydration compounds which enhances whole of the strength and durability performance of the matrix. So these are the chemical reactions what do actually take place in when each of the both compounds are going to get reacted with the water. So when C3S, if you could able to see in, it is going to get reacted with the water, with resulting in the formation of CSH and CH, as well Cu2S, as well the C3A and C4AF also. So likewise, these are the different forms or the reaction products what are going to get formed as a result of the chemical reaction between the cement and the water. So the hydration process do consist of 5 phases. So the phase 1, it is known to be as the initial mixing reaction, and phase 2 it is a dormant period, and phase 3 it is an acceleration period, and phase 4 it is known to be as a reduction period, and phase 5 it is known to be as a strength development period. So if you could able to see in this picture, whole of these 5 phases have been depicted as a curve. So on x-axis we'll be having a time and on y-axis we'll be having a temperature. So with time what is just going to happen in is there will be a liberation of the heat that do happen in. So in the first stage if you could able to see in that phase we are going to call it to be as an induction period where with the initial addition of the water there will be a rise in temperature that is just going to happen in. And when we just proceed into the stage 2, that part we are going to call it to be as a dormant period where there will be a deceleration of the heat that is just going to happen in. That means there will be a decrease in the temperature with time. And in the stage 3 again if you could able to see there will be an increase in the liberation of the heat that is going to take place in. So in the stage 2 is just going to get end at stage of initial setting time, and from therein we could able to see the temperature is going to just getting increased. So in stage 4 again if we could able to see in, there will be a reduction in the liberation of the heat that is just going to take place in because of the non-availability of the water or the cement particles in the loose state to get reacted with it. And there is a hump that can also be seen in the stage 4 which actually says in like the ettringite is just going to get transferred into the monosulfate. And again in the stage 5 they could able to see there will be a steady state increase in the development of the liberation of the heat that is just going to happen in So this is how whole of the 5 phases are going to get defined in the hydration process. So this is a justification of explanation of each of the phases what are going to just involved in the hydration process. So in the phase 1, as we could able to see in there, the first initial thing what is going to happen is the C3A is just going to get reacted with the water, which actually results in the formation of the ettringite. So there will be a higher liberation of the heat that is just going to happen in the first stage. And coming to the second stage, as said, it will be of a dormant period. So you could able to see there will be a decrease in the heat that is going to happen in or going to be observed in that case. So in the stage 3, again you could able to see in like due to the formation of the CSH and CH when the C3S and C2S get reacted with the water, we could able to see there is again an increased state of the heat is going to be seen in. And again in this phase 4, we could able to see like there will be reduction in the heat that is going to be liberated out from the reaction between the cement and the water. And from stage 5, we could able to see in like there will be a steady state increase in the heat that is going to happen in with time. So this is how whole of the depiction of the 5 stages can be observed during the hydration process of the cement. So on x-axis you could able to see in the time, and on y-axis again you could able to see in the heat release. So this is how whole of the 5 stages of the hydration are going to be depicted in. So in 10 minutes we could able to see whole of the part of induction stage is being completed, and after which it is going to get proceeded to the dormant period, and after which it is going to get transferred into an acceleration period, as said, due to the formation of the CSH gel when C3S and C2S come into the picture to react in with the water. And again it is going to proceed into the deceleration period, where there will be a decrease in the amount of the heat that is going to get liberated out from the chemical reaction between the cement and the water. And from there on there will be a steady state increase of the heat that is going to get liberated out from the chemical reaction that do take place between the cement and the water. So this is how whole of the 5 stages are going to be depicted in the form of a curve. And next part of a thing what we are going to discuss is the heat of hydration. So we all know the cement when reacted with the water, it is going to liberate in of heat out, so which we are going to call it to be as an exothermic reaction. So this part of the heat what is going to get liberated out from this chemical reaction is known to be as the heat of hydration. So when water is being added to the cement, each of the both compounds are going to get reacted with the water in order to form in different hydration products in addition to the amount of the heat that is going to get liberated out from each of the reaction. So if you could able to see in this table, the C3A is going to liberate out more amount of the heat when reacted with the water, because of which we could able to see in there will be an initial peak that is going to get formed in, wherein as soon as you add in the water to the cement, the peak is going to get raised up. As well in the second part of the thing, if you could able to see in the C3S will be contributing to the release of more heat when reacted with the water, and followed by C4AF and C2S. So likewise whole of the heat of hydration of each of the compound is going to be looking like. So for 1 gram of C3S when reacted with the water, you could able to see 502 joules of heat is going to get liberated out. So here we could also able to see in the formation of the compounds at each of the stage of the hydration that is going to happen in when water is being added to the cement. So on x-axis you could able to see in the time, and on y-axis you could able to see in the rate of the heat evolution in calories per gram per hour. So if you could able to see in the stage 2, the ettringite, what is going to happen in it is going to get dissolved in. So at the induction stage, that is at the stage 1, when C3A is going to get reacted with the water, it results in the formation of the ettringite. So in the microstructure of this cement also we could able to see in the formation of the ettringite is going to be observed at the early days itself. So that part will actually contribute to the liberation of the more heat. So that's why you could able to see in a larger peak that is going to be happening seen at the stage 1. And when time proceeds in, this ettringite coating retards further aluminate hydration, which actually causes it to have a dormant stage that is going to get developed in the hydration process. And in stage 3 and stage 4, we could able to see the C3S getting reacted with the water, and which results in the formation of the CSH, because of which you could able to have in a peak that is going to get formed at stage 3, and after which you could able to see in the ettringite is going to get transformed into the monosulfate, because of which a hump is being seen at the stage 4, though there is a reduction in the liberation of the heat that is going to be happening there, and after which there will be a steady state increase in the heat that is going to happen during the stage 5 of the hydration process. So CSH, we all know it is a main critical compound which actually enhances whole of the strength of the concrete. So it is going to be replicating the tobermorite mineral. So it is going to be having a shape of a tobermorite mineral. So we are going to call it to be a gel. And this part of the formation of this CHH formation will actually give or results in the formation, results in the strength gain of the cement matrix. And next comes the CH. So it will be of a flaky like substance what we could able to see in the microstructure. So this CH is also going to get formed in the primary reaction when water is going to get reacted in with the water, when the cement is going to get reacted in with the water, and after which you could able to see in the AFM phases and AFT phase are going to be formed, which are nothing but the ettringite on the monosulfate. So at the early age we could able to see the ettringite is going to get formed when C3A is going to get reacted with the water, and after which it is just going to get converted into the monosulfates. So monocarbonates in other product, what is just going to get formed in, that is when the fine limestone aggregate gets reacted with the cement pore fluid. So likewise you could able to see in the monocarbonate product is also going to get formed in. So this is all of the theories what are being suggested by many of the researchers starting from 1870. Even much of the research is also been going on in suggesting some of the theories pertaining to the hydration of the cement. So we could able to see in the Le Chatelier was the first man who actually gave in a theory pertaining to the hydration of the cement in the early 1800. So we could able to see like he suggested the crystalloid theory, after which Mekelo have come into the picture and he have suggested another theory like colloid theory. So likewise there are many of the research what is being going on in cement hydration, wherein they are been suggesting much of the theories pertaining to how the hydration is going to be taking place and how the formation of the compounds are being taking place and all. So this is data what has been taken from a journal published by Elizabeth and Barbara Lothenbeck of EMPA. So this is a part of the theories what are being suggested previously by many of the researchers. So thank you so much.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.